Hello everyone, welcome to lecture 4 of Big Data Analytics. The topic of this lecture is Apache Pig and Hive, which are two important components on top of Hadoop for data analytics. Let's learn more about this topic. This lecture briefly introduces Zookeeper and Oozie and mostly focus on Apache Pig and Hive. What is Apache Pig and some of important operation of Pig, and what is Hive and what are the difference between Pig and Hive, and we will consider important Hive queries and another topic in Hive, which is partitioning, and it's important for querying huge data sets. After this lecture, we expect all the students to be able to explain Pig and Hive and understand the difference between these two topics, and also be able to understand Pig operation and Hive queries, and also the optimization techniques for Hive queries, and of course to know basic functionalities of Zookeeper and Oozie. Hadoop ecosystem, we had this picture in the previous lecture. And if you remember, in the previous lecture, I just explained Apache Scoop. So today we will talk about Oozie, Zookeeper, and Pig and Hive, which are here. These four components. Okay, what is Zookeeper? Zookeeper, as you know, is one of the components on top of Hadoop, which has been implemented in Java, and generally is responsible for coordination of the nodes in your Hadoop cluster. It keeps the track of all information which is needs for synchronizing all the nodes in your cluster. The Zookeeper has 5 main roles that I explain in the next slide. But before that, let's see what is the main requirement of a distributed system, because our Hadoop is on distributed system is really important to know what are main requirement of distributed system. The first one is networking. As you know, distributed systems have networking between different nodes, or workstation. These nodes can be physically close together or can be very far away from each other. So, but it's really important they can make communication, and we have to keep this networking. The second one is scalability. So this means the distributed system must be easily expandable. So which means adding more, it should be easily possible to add some machines or some nodes to the distributed network. Another requirement is redundancy and reliability. This is really important. What does it mean? This means if a node, for any result, if a node fails, it shouldn't affect other nodes, and it should be a copy of that node available to work and doesn't make any problem for the system. And the last one is availability, which means the system must be available and must be work properly 100%. Of course, it's completely one of the things that can make it possible is redundancy and reliability. Okay, they are the main requirements of a distributed system. So now see how Zookeeper can help to keep these requirements. As I said, Zookeeper has 5 main roles. One of them is keeping the information for configuring all the nodes properly. The another one is naming service, which is a technique that you in the networking that make you possible to find a node in a reasonable time among like thousands nodes. So another role of Zookeeper is providing distributed synchronization. Okay, it's completely clear when you have a distributed system with many nodes, and of course we have many resources like memory, CPU. So sometimes some of nodes have to wait for getting resources, and Zookeeper is responsible to make this synchronization between the nodes and coordinate them, just to avoid some of issues like deadlock or starvation, this kind of things. Providing group services, of course, when we have lots of nodes in a system, sometimes we need to provide a service for a group of nodes, and the Zookeeper lead this kind of services. Timelines. This is another important role. As I said in the previous slide, distributed systems needs to have availability, which means if a node get out of the system for any reason, for example, a node failed, so it's really important to quickly have a copy of that machine in the system. So this timing is important because we don't want to make any problem in the system. So Zookeeper is responsible for this, for coordinating these timeline. Okay, next is what is Oozie? Oozie, as you know, is another component on top of Hadoop. So let's see what is the responsibility of Oozie. When we are processing a huge amount of data, so it's of course usually we need several jobs to process this data. The question is how these jobs can be managed. Oozie is responsible to schedule workflows and also manage jobs, Hadoop jobs. These jobs can be MapReduce jobs or streaming jobs, or some of jobs in Pig, Hive, Scoop, in any component, HDFS operation. So what is really important is that all the job needs to be scheduled and run and on time. So Oozie is responsible for executing and monitoring all the workflow in Hadoop. Okay, this is just this picture is just yes, this picture. This picture is just a job scheduler flow chart, which show a periodic scheduling of workflows. Okay, now we want to, as I explained, we just briefly explain Oozie and Zookeeper. And now the main focus of this lecture is on Apache Pig and Hive. So let's start Apache Pig. First of all, let's see why we need Hive and Pig. As you know, MapReduce is very powerful, but on the other hand, it's very complex. So there are not many people who are really skilled in writing and implementing complex Java code. But you can find many people who have enough skill in writing SQL queries and a scripting language. That's why Hive and Pig have been developed on top of Hadoop to help these people and also analyze huge amount of data based on MapReduce. Hive has been developed by Facebook and Pig by Yahoo. Okay, let's have more details about everyone separately. As I said, Pig has been developed by Yahoo. It's a framework on top of Hadoop for analyzing large data. So actually it's for unstructured and semi-structured data. So as you can see in this picture, okay, if you want in Pig, you just need to write a scripting language because it's based on a high-level scripting language. If you want to analyze data, you just need to write in a scripting language, and then Pig can translate this scripting language to MapReduce program. So it's process the data one step at a time, and the benefit of using Pig is a developer doesn't need to implement any complex Java code, and the scripting language is easy to understand and also easy to debug. Let's learn some of main operation in Pig. The first one is loading data. Operation load can load input data. You can see here. I will give you example of this, of all this operation in the next slides. So projection, which is similar to select, which means you can apply a condition close to a set of records. Grouping is possible that you collect some of the records together. Dump and store. Dump operation can display the results to the screen, and a store can save the results to the file system. Aggregation, it includes some of function like average, count, max, mean, and sum. Okay, let's see some examples. Let's consider some Pig operation examples. As I said, you can use Pig to analyze data. Of course, the first of all, you need to read data, you need to load data. Pig store is responsible, is an operation for loading and storing relations. Let's say first, what is relations? When this is your file, for example, your text file that you want to read it, each record or each row is called relation in Pig. So in this example, students, we want to load data from a student txt, which is a text file, using Pig store, and this parameter is delimiter between elements. As you can see here, between each two element, the delimiter is a tab in this example. So we write tab here. So okay, we want to read data from a student.txt, and the delimiter between elements is tab. Okay, now we have to define what is each element. As I said, Pig is for semi-structured and unstructured data, and if you want to analyze data, we need to organize them somehow, So the first element is considered as a student ID, which is integer. The second element, name, and age, and the last one, GPA. So we load this data and put this data in students. In Pig, students is called bag, and each bag is a set of relations. Okay, so now our data is ready in students in bag. So we want to analyze it. The second operation that I'm going to explain is for each generate. This is very similar to select. So in SQL, so we want to extract some of elements in another bag. You can see the student ID is another bag, which will have the result. For each and generate our keywords, we have to write it. So we want to take information from students bag. So I want to extract these two elements, student ID and name. So the result, which is these two first elements, will be saved in a student ID. And a student ID is another bag. Another operation is group by, which group the data in one or more relation. In this example, you can group students by age, and the result would be in another bag, which is called A here. Dump display the output results or any bag to the screen. In this case, in this example, we say dump A, the result from the previous operation. And a store, of course, write the result into a file. You can see here, for example, if you want to write our result in A into an output file, you can write store A, which is this, into the output file, which is called output. Okay. Another operation is count, which is count the number of elements in a bag. So what is really important to know is when you want to use this function, this operation, you need to first use group by statement to group the elements first and then count them. So if you remember in the previous slide, we had this example to group the student based on their age. So now we're going to count the student in each age. So we first write this group by, and then we say, okay, for each A, because A each is a group of students, now count the number of students. So, and the result would be in X. Okay, so in this case, in X we have different age, and in front of each age we have the number of students with this age, in this age. So another operation is order. So this operation sorts a relation based on one or more element. So as you can see here, you can write order. Students is a pack, the first pack, if you remember, which we had all the data in. So order students based on GPA in descending order. So a student order would be another pack with the ordered information. Okay, what is Hive? Hive is a platform on top of Hadoop, which is initially developed by Facebook. It's a data warehouse infrastructure for processing structured data. Attention, is for structured data. And you remember that I said Pig is for unstructured and semi-structured data. So as you can see in this picture, you know, in this picture, if you want to analyze data, you can write your commands in SQL, and then Hive use MapReduce to execute your commands. So you don't need to, as I said, like Pig, you don't need to now Java programming for analyzing your data. Hive also use HDFS to store the data. Okay. What is really important to know is Hive is not a relational database itself. Hive is not a design for online transaction processing, and it's not a language for real-time query and row-level updates. It's really important. You don't, somebody make mistake, but it's really important to know this. Let's quickly review the difference between Pig and Hive, and also compare both of them with the Scoop. Pig and Hive both are for analyzing data, but Hive, Hive, you can see here, the language for Hive is HiveQL, which is very similar to SQL, and for Pig is a Pig Latin, which is a scripting language. In Hive, you can have a table definition, which is stored in MetaStore, but in Pig you don't have a table. You can have a schema, it's optionally can be defined in a runtime. In terms of access, in Hive, Hive use JDBC and ODBC, but Pig have Pig server. So they are the main difference. But if I want to compare Scoop, Pig, and Hive together, so let me just to simply define them in a sentence. As you remember, Scoop is used to import and export data between HDFS and traditional database. So Scoop is just for transferring data. It's not for data analysis, which is completely different from Pig and Hive. Pig and Hive both for data analysis, but Pig is a procedural language platform which use script language for MapReduce operation. But Hive is a platform which develop SQL type language to execute MapReduce operations. This is and also another thing is really important is Pig is for semi-structured and unstructured data, and Hive is for structured data. Okay, and now let's count some of important Hive commands. So the first one is creating a database. A database in Hive is a namespace or collection of tables. So how we can create it? You can just write create database keywords, or a schema, it's the same. And you can write if not exist. You can use it when you are not sure if the database with this name exists or not. So, and the database name. For example, we can create database userdb if not exist. If it exists, so you don't need to create it. Or you can create schema userdb. It's the same. Userdb, it's the name of your database. Okay. Now how you can create a table. This is the syntax here. Let's to explain it through an example. You will use create table. Keywords is create table. If not exist, similar to what I explained for database. And the table name is employee. Now you have to define elements in the table or fields in the table. The first one, employee ID, EID, integer, name a string, salary a string, destination a string. Okay, and you can add a comment if anybody see this table now. What is this? Employee details. This is optional. Row format, delimited, and what is the termination character for fields, and what is the termination character for lines between records. It's the first one is tab and second one is a new line. You can keep it as it is when you are creating database, creating table, and you can say store as the text file. Okay, this is how you can create a table. We will practically learn these commands through the lab exercise. Okay, now we want to load data into a table. So we have created database, we have created table. Now we want to load data into a table. So what we can do, we can insert data using insert command, insert statement. But in Hive, it's possible that you use a load data statement and load data from a file to your table. This file can be a local file system or can be a Hadoop file system. So let's see how we can do it. The syntax is load data, and then you will have the file path. You can write overwrite. This means if this table, you had this table and you had loaded data before to this table, and now you're going to you have to decide if you want to overwrite this the data of this load to the previous data or not. You can write the keyword of overwrite if you want into the table, and this is the name of the table. And of course you can make partitioning. I will explain partitioning later. So local is the definer to specify the local path. When you write the local, which means the path that you write here should be a local path. So if you don't write anything, it's optional. If you don't write anything, so which means it's not a local path, in this case, the HDFS path. Okay, and as I said, overwrite is optional if you want to overwrite the data in the table. And partition is optional as well, but I will explain partitioning later. So let's see the example. Load data, local input. This is a local file from home user sample.txt. Overwrite into table employee. So I have created employee before. So now I want to load all the data from sample txt to my table. And if this table had some information before, please overwrite to the previous information. How to alter your table or change the structure of your table. You may want to change the name of your table. So you write alter table, they are keywords, and this is the name of your table. And then you have to write rename. This is another keyword, rename to, and the new name. So alter table, the name of your table, rename to the new name. For example, in this example, you can see alter table. The table of my table's name is employee. I want to change the employee, rename that employee to imp. So from now on, the name of my table, it's not employee, it's imp. Or you may want to change to add a column, add one or more column to your table. So you say alter table, the name of your table, and then keywords are add tables, add columns, add columns. Then you can add one or more columns here. I have example here. You can see alter table, employee, add columns. Okay, I'm using employee because it's like I didn't change the name yet. Okay, I want to add these columns. Depth, the type is a string, and I can add comment. I have add just one column here, but if you want, you can write comma and add another column or more column. Okay. Or you may want to remove a column from your table. So you write alter table, the name of your table, drop column, and the column name. So I don't have the example here. It's in the next slide. I'll show you. So, or you may want to change the name of the column or the type of the column. So you write alter table, the name of your table, change, this is the keyword, and the column name. Now you can give this column a new name or new type. Like here, alter table, employee, the name of my table, change. Okay, do you remember we had a column with the name of name, name of employees. I'm going to change this name to ename, and I keep the type as before, a string. Or I want to change the type of my column. I write alter table, my table name, change. Okay, I want to change salary, but I want just to change the type, not the name. So keep the name as before and change the type to double. It was a string before, but I have changed it to double. So as you can see, you can easily alter your table. Or you may want to replace the columns. So you write alter table, your table name, replace columns, and then you can write which columns you want to replace. So partitioning in Hive. When you submit a query in Hive, Hive read the whole data set into a table and convert your SQL query into MapReduce jobs, and then run MapReduce jobs over that large table. So this is not actually efficient. So instead of running MapReduce jobs over a large table, it's better to divide the table into some related parts based on the value of some of particular columns, and then run this MapReduce jobs on smaller partitions instead of running on a big table. So it would be more efficient and it would be much faster. So actually this partitioning is easy to query and it's faster. So what is really important is to have one or more partition key to identify the partitions. It's really important. As you can see here, for example, when you are creating table with the columns, here you can partition table based on the particular columns. For example, based on the, I don't know, date, based on city. Let's see this. Yes, let's see this picture. You can see here, this is the table now database, and then we have divided, we have partitioned the data set to like 3 segments based on the date, based on the column date. And it's possible, if needed, if possible, to divide this partition, subdivide to this partition into some buckets, even make a smaller partition if it needs to do it, and it's make the system faster. Of course, it depends on your queries, it depends on your database and your tables, information you have saved in your tables. Okay, this is another example you can see. For example, create table sale. The sale table include person ID, product ID, and date of sale. Okay, we have 3 fields, and we want to partition this table based on date of sale. In this case, you can see each date make a different partition. So usually in this system, most of the queries are based on dates. So it makes it much more faster and more efficient to have partitioning based on date. So as I said, it depends of your system, your queries, and a developer needs to decide which partitioning is efficient, is useful. So we can have more advanced topics in partitioning, like static, dynamic partitioning, if you are interested to learn more, external partition table, outer partitions, So if you are interested, you can have further studies on partitioning. Let's discuss advantage and disadvantage of partitioning in Hive. So based on what I explained, it's clear that partitioning distributes the load of execution. So it would be much faster to execute queries on a low volume of data instead of high volume of data. For example, if you want to search population, it would be much faster to search population from a particular city instead of searching from entire words. So this is but it's really important. When I was explaining partitioning, I said several times that it's really important to have appropriate partitioning. Why? Because sometimes it's possibility of have too many small partitions and too many directories, which is not make it efficient. Even for some of the queries, maybe it's get even worse. For example, if you have like some queries like group by, just imagine if you have a grouping population of like China. So of course it takes a long time compared to grouping of the population in Vatican City. So that's why I'm telling it's not always 100% that you will have efficient when you are efficient system when you're using partitioning. It's really important to see which partitioning is appropriate and what are most queries that you need to use and run, and then based on that you have to decide about partitioning. Okay, let's explain another command in Hive, select where. So you can see you can select some of columns in table, and you have say which table, and then you can put a condition here where for example you can say select a star. When you say a star, means you want to select all columns from your tables. If you want to have a specific columns, then you can write the name of columns instead of a star. Okay, here we say select a star, means select all columns from employee is our table name, where, and this is the condition, where salary is bigger than 30,000. So the output would be the information, all information of employees who have salary more than 30,000. Select order by. This is another statement, another SQL query in Hive. You can select as before, sum of columns or all columns, and then you can order it based on one of the columns. Here is the example. I say select ID, name, depth, 3 columns from employee, which is our table name, and then I say order it based on the depth, which is one of our selected columns. So you will have results for ID, name, and depth, and the results would be ordered by depth. Another syntax is select group by. This is the general syntax we are using for select, and here just see the example. We want to select depth and the number of the employee in each department. So we will select this information from employee table name. We want to group all the information based on their department. And then finally, as the result, as the output, we will have department name and the number of employee who are working in each department. So this is the example for select group by. This table summarizes important retrieving information. The first function is retrieving information generally. So select from the columns and from the table a where condition. So this is the general syntax for retrieving information. Retrieving all values, so you can say select a star from table. Here is your table name. Retrieving some values, okay, you can say select a star from table and then just put a condition here where, for example, a special column should be equal some values. Retrieving with multiple criteria, so you can repeat the previous one, select a star from table where, then instead of one condition, you can add more than one condition, as many as you want, but it should be, of course, reasonable. Retrieving specific columns, very clear. You have to select the column names, one or more, from the table. Your table name and the column's name. Retrieving unique output. Okay, sometimes when you are retrieving some columns, then some of columns have the same number for some of records. Then you can say, okay, just repeat it once if it makes sense in the output. So you can select, and if you add this thing as a keyword, then you will have only one time of the same values, and it just remove the repetitions in the records. Okay, sorting, of course, we explained it before. You can sort the output, select the columns from table, and then you can order it by one of the columns which has been selected here. Sorting reverse, again, similarly, you can order it, but at the end you have right descending. It's a kind of reverse sorting. Counting rows, so you can select, say, count a star, which count the records from the table. Grouping with counting together. So we had this example. So you can say, okay, select owner or any field, any column from the table and count a star, but you need to group the table, the records, based on the column that you have written here. We had this example and I explained it in the previous slide. Maximum value, okay, you can select a column and take the maximum value of that column as a label from your table. And this is your table name. Okay, this table is not new. We explained the syntax of this different type of retrieving in the previous slides. Built-in functions, as you had seen in the examples, for example, we had count, we had max, there are some of built-in functions with Hive that you can use them, simply just use them, like round your number, floor, save. So you can see the description in front of each function. So we are not going to go through them one by one. They are very simple, and you can read the description of each one, and it's simply understandable. Okay, how to create a view in Hive? Let's see what is view. View in Hive is the same as view in SQL. If you remember, views are virtual tables which will be created based on the user requirements. If user wants to make queries on selected data, so it's better to create view for them to work on view instead of working on original table. It's good in terms of the security and also in terms of the efficiency, because instead of working on all records in an original table, sometimes it's better to work. It's faster to work on a part of data in view. So let's see how we can create view in Hive. This is the syntax: create view. If not exist, this is the if exist. Okay, that's one. But if not exist, this name you can create it. This is optional. And then you can select the columns, and if you need to put some condition, you can do it. Here is an example: create view imp 30,000. This is the name. Create view is the keyword, and imp underline 30,000 is the name of the view. As okay, now we can define our view. Select the star from employee, all the records from employee where salary is bigger than 30,000. So this view is created for information of all employees who have salary more than 30,000. So in some of the working place, probably they want to do some special queries on this particular of employees. So they can make a view, and of course it's much faster than if they want to make queries on this special people, special employees. So it's better to create a view, and it's more efficient to make queries on this view instead of making queries on the whole table. Okay, how to drop a database, table, or view? Very simple. You can see, you can just write drop database if exists. For example, if you want to remove your database user DB, just say drop database if exists, the name of your database. If you wanted to drop table, just write drop table if exists and the name of your table. If you want to drop a view, just drop view and the name of the table. This if exists is optional. You can write it or you can just leave it, ignore it. Join. is one of interesting statements in SQL query. It's used for merging records from one or more tables, and it should be based on the common values of each table. So these values are related to foreign keys and primary keys of those tables. I will explain it more in the next slides by giving examples. So just now there are 4 different types of join: inner join, left outer join, right join or right outer join, and full join. And this is a general syntax. I'm not going into details of this syntax because it looks a little bit confusing. It's better that I explain the syntax and the concepts through examples. Okay, inner join. Can you see, as you can see in the picture, inner join, this is one table. We are explaining the concepts for 2 tables, but it can be more than 2. As you can see here, inner join return all records which have the matching value in both tables. This is the inner join. Left join or left outer join, which is this one, return all records from the first table plus the matching records from the right table. If there is no any matching record in the right table, then it's return null for that record. So right join or right outer join is similar to left join, but for the right table. It returns all records from right table plus the match record from left table. And if there is no any match record in the left table, in this case, just return null. Full join or full outer join combine all records from both left and right table. And the join table contain all records from both tables. If there is matching record from both sides, that's perfect. If there is no any matching record for each side, then return null for that side. Okay, let's see example. Let's see an example for inner join or join. As you can see, we have 2 table customers, which has information about customers, and orders, which has information of all orders. So as you can see, in customers table, we have ID, name, age, address, and salary of each customer. And in orders table, we have order number, date of order, customer ID, and amount of order which has been placed. So as you can see, the share value, because we want to combine these 2 tables, the share value for these 2 tables are ID numbers. You can see the customer ID here is the primary key, and customer ID in this table is a foreign key. So these are 2 share column, and we have to make join on the value of these columns. Okay, so let's see the syntax, and then I will explain more. We want to make inner join. First of all, we have to select the columns that we want to show in the output. As you can see, select CID, C.ID. What is C? In the second line, you can see that we have defined C is the customers table. So we wanted just to find a shorter name for our tables to refer in this query. This is just for this query. We say in this query, when we write C, it refers to customers, and O refers to orders. So back to the first line, select C.id, which means from table customers, select ID. From customers table, select name and select age. This is from customers table. And O back to orders table. So from orders table, select amount. So these are 4 columns that we want to present in the output. Okay, so we have selected the columns. Now say from which tables? From customers, which we called it C, join, this is the keyword for inner join. Join orders, which we consider is as O, on. So 2 keywords for inner join is join on. Now, what is the condition? We want to join them on a common value. It's ID from customers table and customer ID from orders table. They have to be equal. Okay? As you remember, inner join return all the records which have matching values from both tables. So what will happen? We have to find the records with matching values. Let's start from the first one. One customer with ID 1. Is there any matching value here? Can you see in the customer ID, is there any number with 1? No. So we cannot combine, we cannot show these records. Go to the second one. Customer ID 2, number 2. Is there any matching value in this table? Yes, this is the matching value. So one of the records in the output would be for customer ID number 2, name Khilan, age 25, and the amount is 1,560. Is this one? Yes. Let's go to the next one. Number 3, customer ID number 3. Is there any matching value here? Yes, we have 2 matching value here. Okay, so we can define 2 records. This customer with this name and age has placed one order with 3,000 and another order with 1,500. So how about customer ID number 4? Yes, we could find a matching value here. So this is the last one. How about 5, 6, 7? Is there any matching value in the orders table? No. So we don't have any record. So inner join return all records that have matching value in both tables. Okay? So let's repeat the example for writing a left outer join or left join. If you remember, left outer join return all the records from the first or left table and the matching records from the right table. And if there is no any matching record, it's back null. Okay, so let's show the syntax and then we will discuss the output. Okay, as you can see, we first select the columns. Okay, you know the C means customers table and O means orders table as we define here. Okay, so select from customers table, we select ID and name, these 2 columns, And from orders table, we select amount and date. Amount and date. Okay. So from customers, it's called C, left outer join. This is the keyword for left outer join. We want to join customer with orders on. This is another keyword. And where the share columns, primary key here and foreign key here, are equal. So what is the output? I said left join return all records from left table plus matching records from the second table, and null in case of no matching value. Okay, start from the first record. Okay. Is there any customer ID in second table with ID number 1? No, there is nothing. So we have to write, because we write all the records from the left table. So we write the first record, but since there is no any matching value in orders, it returns null for amount and date. So this means this customer has not placed any record, any order until now. That's nice information. This is good for sellers to know if their customer has been placed any order or not, and if they have done, how many they have done, you know. So the registers are customers actually. They may register, but they didn't put any place, they didn't place any order. So the second one, customer with ID number 2. Is there any matching record here? Yes, we have this one. So we will write it. Customer ID number 2, ID and name from customers table. And of course, amount is 1,560 and the date is here. Okay. Second, the next customer number 3. Is there any matching value here? Yes, we have 2 matching value. So we will put 2 different records. One, combine this with the first order, and the second one combine, write the information for customer with the second order. You can see here. One order with 3,000, another order with 1,500. Okay. The next customer, number 4, is there any matching value here? Yes, we have 1 order placed. So write it with the matching value. ID 4, name, and the amount, which is 2060, and the date. Okay. How about customer number 5? Now, there is no any matching value here. We write the information requested for this customer, but we have to write null for columns from orders table, because there is no any matching value. And similarly for customer number 6 and number 7. As you can see, the output is useful because the seller can see the all registers customers, and then also can see if the customers has placed any order or not, and if has placed order how many times. That's a really nice information for sellers. Okay, let's go and see example for right outer join. Again, we have customers and orders table. Let's see how's the syntax. Okay, so we select ID and name from customers table, amount and date from orders table, and we want to have right outer join to combine customers and orders tables. So this is right outer join, there are keywords and on. Okay. The condition is, of course, the common column should be equal, the value of common column. Okay. If you remember, I explained the right outer join return all records from right table or second table plus matching records from left table, and if there is no any matching records, return null. Okay, let's see the output. Okay, in this case, the output is the same as inner join. So because okay, let's explain and you can probably guess why the reason. We start from, because we wanted to have all record from the right table, so we will start from right table. So the first one is this. The customer ID is 3. Is there any customer ID with 3 here? Yes, of course. Should be, because this is the foreign key and this is primary key. Of course, any customer ID that you can see in orders table, of course, there is information about that in customers tables. So that's why you can always find matching value for any record in orders table. And that's why at the end you will have the same output as inner, because there is no any record in the orders table that has no any matching value in the left side. Okay, as you can see here, okay, is there any record with customer ID 3 in the left side? Yes, there is. So we will write the information. Again, second record, we start from right table because this is right outer join. Is there any record with customer ID 3 in the left side? Yes, it is. So we will write it. Is there any record with the customer ID 2? Yes, there is. Of course, there is always matching value here, because I said this is foreign key in the orders, and of course primary keys in the customers are always available. So we will write it. And last records, any customer ID with value of 4, yes, there is. In this side, there is matching value. So we will write the requested information here. That's it. In this case, the result of right outer join is the same as the result of inner join. And it's not, you know, it is for this example. It's not going to happen for every example. Okay. Let's see how is the output of this example for full join. Okay. This is a syntax. We want to select ID and name from customers and amount and date from orders. We want to make full outer join or full join. Okay, on these columns. Okay, so ID, which is primary key in customers, and customer ID, which is Frank. So if you remember, as I explained, full join return all records from both tables and try to find the matching values. Okay, we'll start first from the left table. Doesn't matter if you start from left or right, it's full join. First one, this customer has any order in the orders table? No, there is no. So we'll write it and put null for amount and date. Customer number 2, any matching value? Yes, there is. So we will write the matching value. Customer number 3, any matching value? Yes, we could find 2 records. So we have to repeat it for each order. Customer number 4, yes, there is a matching value here. So we'll write it. Customer number 5, 6, 7, no matching value. So we have them, but with null for date and an amount. Okay. And now we have to repeat it for the second table. We'll start from the first one again. Is there any matching value on the other side? Yes, we have two matching value. We have one matching value here for customer number 3, so we have to write it. This one, customer number 3, any matching value here? Yes, there is. Write it. Number 2, matching value? Yes, there is. Customer number 4, matching value on the left side? Yes, there is. So, as you can see, it's the union of outputs for left outer join and right outer join. If you union the result from left outer join with result from right outer join, it would be result for full outer join. Okay, that's it. In this lecture, we had discussion on Zookeeper and Oozie, and I introduced two important components for analyzing data, Apache Pig and Hive, and I clarified the difference between these two components. We practice Pig operations, we practice Hive queries, and also we learned how partitioning in Hive can make more efficient queries for huge data sets. In the lab exercise, lab session, we practically work on Hive queries. Thank you so much for watching this video.